Number 25 on page 243 is the first example that we have that involves an inequality with a rational expression. It asks us to look at the function f of x equal to x minus 1 over 2x plus 3 times x minus 4, and we're going to look at the different sections of the graph, and specifically where the zeros are, where the sections that are undefined, what positive sections there are on the graph, and negative sections. So to start with any rational expression, we find the zeros and the undefined values, similarly to what we did with the polynomials, finding the zeros first. So we find the zeros in the numerator. They're in the numerator. The undefined values are in the denominator. And when we look at the function, what we're going to see is that the values in the numerator that could be 0 are really just one value, which is x equals 1. In the denominator, we have two values that make it undefined, and that is that x equals negative 3/2 and x equals 4. So we've now answered parts A and B of the problem. Our 0 is at x equals 1, and our undefined values are at x equals negative 3/2 and x equals 4. So to solve the other two parts, we're going to use a sign chart, just like we did with our polynomials, but we're just going to add a few more details for clarity. So again, we're going to draw a number line. We're going to put not only our 0 on there, but also our undefined values, because they are the points that divide the graph again. Okay, so the smallest of those is negative 3/2, and then we have 1, and then we have 4. Now I'm going to mark up above each of these that at negative 3/2 we're undefined, and also at 4 we're undefined. And this is going to help us when we're writing our parentheses later on in other problems. Do we need a bracket or do we need a parenthesis? And then of course we have a 0 here at 1. So the values I'm going to pick, before negative 3/2, I'm going to use negative 2. Between negative 3/2 and 1, I'm going to use 0. And between 1 and 4, I'm going to use 2. And again, you can use any value you want in between them. So I'm going to substitute negative 2 in, and just like in our polynomial inequalities, I just really need to know the signs, not necessarily the value. But now I'm going to have fractions. So if I substitute negative 2 in the numerator, I get a negative number. If I substitute it in the denominator, I'm going to have a negative times a negative. So I have a negative over a positive. So the first section of the graph that I'm looking at will be negative. Do the same thing with 0. I get a negative number over a positive for the first parenthesis and a negative for the second parenthesis. So I have a negative over a negative. So that section of the graph will be positive. And then in between 1 and 4, substituting 2, I get in the numerator a positive value, and in the denominator I get a positive in the first parenthesis and a negative value in the second parenthesis. So I have a positive over a negative, so this is negative, and I realize that I need another value in my sign chart, so value greater than 4, a value greater than 4, so I'm going to use 5. And when I substitute 5 into the rational expression, I get a negative over a positive times a positive. So overall, the rational expression will be positive. So now I can mark the sections that are positive on the graph. They occur between negative 3 halves, and 1. And I'm going to put the union symbol because there's another section from 4 to infinity. And then the sections that are negative are from negative infinity to negative 3 halves, and also from 1 to 4.